Just getting the title of the stream set up here, folks. Okay, so the stream is rolling. All right, so just gonna adjust my camera zoom level here. Now, as you guys know, I'm sort of involved in a little bit of low-key manufacturing these days. Nothing of major consequence, but I'm down in a machine shop once in a while and seeing some of these tools that this textbook shows, and it's actually, it was kind of funny for me to, so I'm on page, what is this, 128 of the textbook. Some of these tools that you see here are things that I'm seeing in these machine shops, and there's lots of places like this around in Chilliwack where they're doing lots of interesting fabrication. And even here, when this textbook was made quite some time ago, they had a computer-controlled milling machine, and the university has these things. And not only do we have them, we also have a manufacturing program where if you have something that you want to design, you can model it in a computer, and we have machines that will mill the metal to build what you want. So this whole idea of designing something, and then as you're designing it, you need to section through it just to look at the thicknesses of metal, and you know, maybe you're trying to save weight, maybe you're trying to increase strength. So for example, I am hoping to build my own set of mountain bike pedals here at the university. I used to use what are called clipped pedals. So you had a little binding, then you'd step into the pedal and your shoes got a little binding on it, and it would click into the pedal and it would hold your foot in place. I had a couple of painful crashes because I'd bail, my foot wouldn't come out of the binding, and the bike would land on top of me, and I'd twisted my ankle a couple of times, and I know people whose racing careers were ruined. Now the pedals I'm using now, they're called flat pedals, but they don't really hold your foot in place really well if you're going over some big bumps. So what I'd like to do is design a pedal that's got a more low-key clipping system, or uses super magnets to hold your feet in place on the pedals. I don't really like the magnet idea, but so for some of these simple problems, you know, any one of us can design a solution. And now, you know, you could come to the university with your idea, and for not a whole lot of money, they'd have machines that can draw this stuff up. And of course, the good part of that design process is, like I say, evaluating how this thing is coming together, and looking at how much metal you're proposing to use, and you know, try to use as little as you need to get the job done. So we're going to be talking about how we cut sections through things. So I'm going to go to page or where the chapter starts here. Hold on a sec. No, not 12, chapter 13. There we go. Okay, page 156. Okay, so I'm on page 157 here. So there will be lots of situations, and this happens in buildings as well. So we cut sections through buildings, just like we're going to be talking about cutting sections through parts here. So when you look at the outside of the building, you have no idea where open areas may be. You have no idea how high the ceilings are inside. So the way that you move through the space on the inside of that building is not apparent from the outside. And even if you were to look at a set of plans for the building, you might not be able to determine where these vaulted areas are. You might not be able to tell where, you know, there's a big, like an atrium that goes up to the roof by looking at the floor plan. So sections are required for design of buildings, and also for design of smaller scale things like these objects that we're looking at in the textbook. So here we've got just a part on the top of page 157, and they've just drawn a slot, or yeah, drawn a slot going down the middle through it, just sort of to imagine that you're taking half of this part and you're going to pull it away so that you can see what it would look like if you took a saw and cut right through the center of it. So sectioning things is done very frequently in both architecture and also mechanical design to give the fabricator or the builder a better understanding of how they need to construct the object or the building. So up till now, we have not used any shading or hatching in our drawings. So here in the bottom of page 157, you can see that the same part is being drawn in section, and that a series of diagonal lines at regular spacing are being used to show where the sectioned areas are. So you can see how this thing has like a square hole in the middle, and it's got a countersunk portion here, so we call this a countersink, and then there's a hole that goes, a cylindrical hole that goes right through to the bottom. So when we cut a section through it, you guys can see how we would arrive at this sectional shape here by looking at the 3D showing the countersunk area and the square hole and the round hole that goes right through to the base. Now these little series of arc lines here, which are just kind of drawn as a stylistic hatch here, we'd never draw those. So you see that they don't appear in the drawing below, but we do show this diagonal hatch. Now, the kind of lines that you draw for the hatching is important because they do tell the fabricator what kind of metal you're proposing for this thing's construction. Now, usually there'd be a note on the drawing that would say, you know, this needs to be mild steel, hard steel, stainless steel, bronze, brass, aluminum, whatever. But along with that, the industry does have standards for what a series of solid lines represents as denoting a particular material that's going to be used in sections. So we will look at some more of that in a little bit. So in terms of views that would be used to draw a part like this. So here you can see that we've got a section that goes right through it. Now, instead of a front view, they're saying that you could use a section. Now, this section is totally fine, but you know what? It's actually missing some hidden lines. So you guys can see right here, these hidden lines, they would have shown up in the front view, and they would still be drawn in the section. So we would draw those hidden lines coming down because, of course, there is this slot in the background, and we would expect to see those hidden lines in this view. So it's a pretty simplistic object. So we've got a center line that comes down from the centers of the hole, and then we've got the hole itself. So that's a pretty straightforward piece. Now, when things get a little bit more complicated, especially like this kind of an object here, where as we look at both the section and the top view, you can kind of imagine what this shape looks like. But there's some oddball aspects of sectioning objects, especially if the object has a hub and a flange, and then these connectors between different hubs, and these are called webs, these little bits here. So you can see there's this diagonal piece that's coming down. Now, I wish they had a 3D angle of this so that you could really see what's happening, because you've got this whole sort of oblong thing at the bottom here, which is made out of thinner material, and then it thickens up where the holes are on the ends and in the middle. And then connecting these two flanges, there's this piece that angles up and strengthens the connection between them because you've just got this flimsy piece of metal here. So this keeps this whole thing stiff, but without having to make the whole thing this total thickness. Now, what's weird about this, and I'm going to drop the camera in because I'm zoomed in a little far out here, and there's some details I want you to see. Woo, sorry about that. noticed everything's a bit sticky because it's been sitting in moisture all night, so it's a little sticky. So hopefully that's a little easier for you guys to see. So the section line that's being drawn through this object, of course, is right through the middle of it. So when we indicate a section on a drawing, there's lots of different graphics to do it. So in architectural practice, let me grab my trace paper here. So if we were doing this architecturally, and sometimes objects like these do get designed by architects, quite frequently actually, and we'd show a section line like this. And we'd have a little tail on one end, and we'd have our section head, and then an arrow. Drawing number, page number. So this section through this thing is would be shown on sheet A6 in a drawing set, and it would be drawing number 1. So that's an architectural section indicator. Now, if it was mechanical, there's lots and lots of different graphics that they might do. Some of them do a line right across, and then they have triangular arrows, and then it might just say A on each end. So this is section A, and they'll probably draw it on the same sheet. If it's on the same sheet, they may not even put a letter designator or anything on it. You can just see that there's a section here. The arrow points in the direction that the section is looking, so we're obviously looking in that direction in both of these cases. And so finally, another method that you'll sometimes see is a dashed line. And it'll be pretty heavy, like object line heavy or maybe even heavier. And sometimes they'll have an arrow that comes off the end of it, like so. So these are all sort of mechanical style section graphics. And I actually don't care which one you use. I'd say we'd probably stick in mechanical mode because the architectural bubble takes up a bit of space. So if we are literally cutting through the middle of this thing, then the question is, why does the section show the bottom plate or the bottom flange sectioned, but why doesn't it show our little web here sectioned? It doesn't. It shows it as if it's in the background. So if you're looking at this thing, you would kind of expect, if we're truly cutting through the middle of this thing, you would expect the section to look like this. I'll just draw this one little piece here, not the whole thing. So we would expect this whole thing to appear sectioned, would we not? Does anybody want to take a stab at why this is not done? It is. See, if this piece here was shown as sectioned, it might give someone the idea that in the drawing, this web is full depth. So instead of it being here, this web would go all the way to the outside. And so, this thing would be full thickness, right? From one side to the other, but it is not. So because our little piece of web here is only partial thickness, what this helps the viewer to understand is that this piece is not full depth, it's only partial depth. And so we only show fully sectioned that part of our object that is continuously of this thickness from the front to the back. So this ends up being sort of a symbolic representation of how the object is fully drawn. This is also done in architecture. So when we have, like a little buttress or a reinforcing component, so it might be made out of concrete, might be made out of steel. This convention, where a partial width um, element in an object doesn't go the full depth, and then it doesn't get sectioned. So on one hand, it could be confusing, but this is going to be used all over the place in sort of this next assignment. So it's very good to keep in mind. So yes, we are sectioning through it, but this little web, because it's not full thickness, isn't shown sectioned. But the part beneath it, of course, right? This, the bottom part of the object, which is from this side to this side, of course, that is, 9 mils thick and is continuous right from one side to the other. So this part is shown sectioned, but not this part in here. So that's definitely potentially confusing, and I just want to sort of get that rolling right now. Okay, so if we're cutting through a cylindrical object, it's actually a little bit easier. Now, this particular example has what we call a keyway, and so you can see it here. Drive shafts, when they're inserted into these things, in manufacturing equipment, they'll have the cylindrical shaft, but that shaft will have a little piece that pokes up, and so that little part on the rod that pokes up goes into the keyway and just allows you to get more torque on this thing, so that if it's that drive shaft is turning this hub and flange, it'll be able to do so. It won't just slide around inside it. So when we section through it, we're going to see the center line through the middle of the hole, the center line for our bolts. And you can see that these ones here are countersunk. So there's a larger cylindrical hole that's cut, and it's recessed. So that way the bolt can be down and recessed, and you won't see it. And so then you can also see the keyway is shown as well. So all of these components, when we're sectioning through an object, are part and parcel of drawing these things. So if I was drawing this thing, all I need is a top view and a single section. So a top view looking down on this thing, and a section cutting through it. And that's all we need, is just two views. Let's take a 5-minute break here, folks. I'm just going to go and grab my coffee, and we'll get started. So it's 9:30 now. Let's come back. We'll make it 10. We'll come back at 9:40 and carry on.